Good morning again, and welcome back to my YouTube channel. Thanks so much for those that have subscribed to this channel. To say very big thank you. Still the online science tutor. I'm Organitica Caroline, a graduate of petroleum engineering technology. We started a series on heat energy, the calculations involved in heat energy in our last video, and we could not adequately complete all of the calculations involved in heat energy because heat energy is actually vast, and we wanted to make it a series so that people that have challenges with solving for linear expansivity can just go to that particular video and download that, while other people that are having other issues, like people that have issues with calculating regulation of the temperature scale and temperature interval, will be able to go conveniently to that video and download that. So we started this series because of the fact that we understand that there are so many African students that have challenges understanding the basic concepts of science, and so we wanted to address especially the calculation aspect of the sciences. And so we started a series. Last video was on heat energy, and we attended to linear expansivity part and the calculations involved in linear expansivity in heat energy. So today we'll be looking at the conclusion of that series on heat energy. So we'll be looking at calculations that involve the temperature interval, and then we'll be looking at calculations that involve the quantity of heat that will be supplied to the body under certain conditions. So, temperature intervals. Physics. So today we are looking at calculations on temperature intervals. Okay, so we're looking at calculations on temperature intervals. Oftentimes in science, there are some very specific units that we work with. So for temperature measurement, we have various scales of measurement, but at secondary school level, the two basic scales that you find most commonly used. So the two basic scales that you find most commonly used are the Celsius scale and the absolute scale. So for the Celsius scale, we have, assume this is my thermometer, this is my upper range of 100 degrees centigrade, and this is my lower range. So we have this being my lower limit, and this being the upper limit. So the upper limit corresponds to 100 degrees as the temperature of boiling water, while the lower limit corresponds to 0 degrees, the temperature of ice, that's freezing. But for the Kelvin scale, also known as the absolute scale, we have this as 273 Kelvin, and this is 373 Kelvin. So in that case, you still have that the range of difference between the upper limit and the lower limit is going to be 100. So for example, range of limit for the Celsius scale will be 100 minus 0, which is equals to 100 degrees C. While for the Kelvin scale, it's going to be 373, 273 to still give us 100 Kelvin. So these are the two main scales that you work with, the Celsius scale and the absolute scale, which is the Kelvin scale. If you observe very well, when I wrote the Celsius scale, there was a degree sign attached to it, but it's not applicable to the Kelvin scale. So the absolute scale doesn't have degree Kelvin, it's just Kelvin. While the Celsius scale has degree Celsius. So that's just something for you to take note of. But you see that their interval range, the range between, that's the difference between the upper limit and the lower limit, is still 100 for both. Alright, so oftentimes we are going to be making reference to this. Now, calculations that involve thermometer measurements. So if a thermometer is graduated, it is graduated using these as standards. That's my lower limit and my upper limit. So there are times when you'll be given a calculation that involves a scale that range within, let's say, the upper limit of that scale is 49 and the lower limit is 23, and you'll be asked to interpolate. But don't forget, the standard is still, the upper limit must be 100 for boiling water and then 0 degree, so for freezing ice. So whatever you are given, I'm going to advise that the first thing you do is to bring out your normal temperature scale. That's the standard, which is going to be 100 degree for the upper limit and then 0 degree for the lower limit. So easily interpolate your values. So we're going to check some questions and solve so that you see what I'm talking about in detail. The reason why we are making these calculations is because of the fact that sometimes a thermometer can be graduated in millimeters instead of this degree Celsius and degree Kelvin. So if I want to know what the reading should be in degree Kelvin, I can easily interpolate and solve, and then I'll get what the value should correspond to. So even though it was given in millimeters, I can know the corresponding value in degrees Celsius that it should give me. So that's why a basic understanding of this is very important. You need to know that your upper limit is the temperature for boiling water, which is 100 degrees Celsius, and your lower limit is the temperature for freezing ice, which is 0 degree. So whatever interpolations we are going to make is going to be around that range of values. So we just compare, and then we are able to get what the corresponding values should be in our degree Celsius. We're going to take examples so that we'll be able to drive home this point. Alright, so our question said a thermometer has its stem marked in millimeters instead of degrees Celsius. The lower fixed point is 30 millimeters and the upper fixed point is 180 millimeters. Calculate the temperature in degrees Celsius when the temperature rates 45 millimeters. You know, the first thing I always say is that whenever you're given a question, the first thing you're expected to do is to bring out your data, because that's what we're going to use to solve, so that whatever formula we have to impute our data into, we can easily just bring out the formula and then impute the data as we go along. So first thing first, data given, we have the lower fixed point as 30 millimeters, and then we have our upper fixed point as 180 millimeters. And finally, we were given that the temperature it's reading presently is 45 millimeters. So 45 should range between the 30 and the 180. So having done this, having brought out your data, what you do next is to write the corresponding values that you are expected to get in the degree Celsius. So you also bring out another scale like this, where you have your upper limit and you have your lower limit. So don't forget that your upper limit for degree Celsius is going to be 100 degree. That's the temperature for boiling water, and then the lower limit will be 30, will be 0 degree rather. So the lower limit will be 0 degrees Celsius, and this is what should correspond So this becomes our S. Please take note. If your question states that, if the question had given us everything in degree Celsius and we are finding what the corresponding temperature would be on this thermometer that is marked in millimeters, our value of X will be this way. So your ability to correctly interpret the data you are given, interpret your question, is going to go a long way to determine whether you are going to be right in your calculation or you will be wrong. So for this one, I'm going to now write, our formula is upper fixed point minus lower fixed point over the mid-range minus lower fixed point. So this will give us 180 in this case minus 30 over 45 minus 30, and it should be equal to, same applies here, 100 minus 0 over x minus 0. Okay, so if you do this, you should get 180 minus 30 should give me 150 over 45 minus 30 should give me 15. Should be equals to 100 minus 0 should also be equal to 100, and then over x. So cross multiply. 150x will be equals to 100 times 15. Therefore, my x will be equals to what? 100 times 15 over 150. Therefore, S will be equals to 10 degrees Celsius. Okay, so I want to believe that we understand the procedure followed. So we simply just wrote out our data and then we wrote out our formula. So the formula is the upper fixed point of the thermometer 1 minus the lower fixed point over the mid-range minus the lower fixed point should also be equal to whatever the upper fixed point in the next thermometer we are considering minus its lower fixed point over the mid-range minus the lower fixed point. So you saw that if you bring out your data very correctly, you are not going to have issues when you are interpolating. So you just have to just follow the question and ensure that you interpret your question correctly. Calculations that borders on temperature range and temperature interval that involve the upper and lower fixed point are very simple. All you need to do is to ensure that you understand your question and you bring out the correct data. If you do that, there's a 100% chance that your answer will be correct. But then if you interchange your values, there's also a 100% chance that your answer will be wrong. Okay? Alright, so we'll take another question. Something else that will show the other way around for this question. So, our next question says, a platinum resistance thermometer has a resistance of 4 ohm at 0 degrees C and 10 ohm at 100 degrees C. Assuming the temperature changes uniformly with the thermometer with the temperature, calculate the resistance of the thermometer when the temperature is 45 degrees. Don't forget that they already gave the question that, and the question is making an implication of that the temperature is varying uniformly with the resistance of the thermometer. Just for JAM candidates, if I see a question like this, for example, we are going to be given different options of A, this, B, that. I know that whatever I get as my answer should be within the range of 4 to 10. It should not be less than 4 and it should not be greater than 10, because the temperature increased from 0 to 45. 100 minus 0 over 45 minus 0 should be equal to upper limit 10 minus 4 over mid-range x minus 4. Okay, this would be equal to 100 minus 0 is still 100 over 45 is equals to 6. Since 10 minus 4 is 6 over x minus 4. At this point, we can cross multiply. So 100 into x minus 4 should be equals to 6 times 45. If I open up this bracket, this becomes 100x minus 400 should be equals to 6 times 45. We simply had to just bring out our diagram from our question. So you see that questions that borders on the interval range, that's temperature interval range for heat energy, the calculations that are under that are going to be just in two ways. You see that the first way we saw the question we saw earlier, where x will be on the scale that we are trying to compare to the Celsius scale, or it's going to be on the Celsius scale that we are trying to compare to the scale we are given. It's just a two-way thing. So depending on the question we are given, if you write out your question, please just place your data, just draw out. The best option is still just to draw out your temperature interval scale, and then impute every value you are given. If your question gives you values for your Celsius scale completely, you know you are going to be solving using something like this. So it's going to be on this kind of, your calculation will take this shape. But if your question is asking you to compare a given temperature scale and everything has been given to you there, that means they gave you your upper fixed point, they gave you your lower fixed point, and then they gave you the mid-range. So what you are looking for is just to compare it to the Celsius scale. You are going to do something like this. So the guiding principle is still simple and straightforward. For every question you are given, try to understand the question and bring out the schematic diagram. Like for this one, we just needed to bring out the temperature scales to know that this, we were given 0 degree, and even if they did not spell it out, please don't forget that your lower limit for the Celsius scale is 0 degree and the upper limit is the temperature for boiling water 100 degree, and so this becomes the mid value. So if our question already gave us everything we needed in the Celsius temperature scale, we just interpret everything on the temperature stem like this. We're just using this to mimic the temperature stem. So we know that 100 was given as the upper limit and 0 was given as the lower limit, and then we compare to x. So we just solve, impute, and then we'll solve. Don't forget the formula still remains the upper limit minus the lower limit. That's upper fixed point minus the lower fixed point, all over the mid-range point given minus the lower fixed point. So you do that for the scale 1, and then you use it to compare to the scale 2 that you're given. If you do that, if you interpret your question correctly, there is hardly any reason why your answer should be wrong. Okay? And I hope you've been able to get value today. So the last thing I'm going to say is that for JAMB students, if I'm given a question, because I'm also being tried to see not just my accuracy or my speed, there are also some questions that, based on the range of values given, I may not actually need to go through all the process of solving like this to know what my answer should be. if I understand the concept very well. So that means that like for this question, the options they gave, I think number 1, like the A was 10.4, B was 2.3, C was 3.7, and then the D was 6.7. If I'm given this kind of question to solve, I know that from 0 degree to 45 degree, the temperature increased. So I'm not expecting my value when I finish solving to be less than 4 degree here, which is the lower limit for this temperature. That's the lower fixed point. And I'm not also expecting my value to be greater than 10, because the question already stated that the upper fixed point of this temperature scale is 10. So I shouldn't be expecting an upper fixed point that will be an answer that will be greater than the upper fixed point I've already been given, because my upper fixed point of 10 degree corresponded to the upper fixed point of 100 degree. So 45 degree should not give me anything greater than 10. So I hope you understand that. So when I see the options of values given, the range of answers, I can easily know what should be the probable answer to the question I'm solving, even without putting my pen on paper. That is if you understand the concept very well. That's not to encourage that you don't solve, you just guess your answers. No. That's to encourage you to know what your expected range of value of answers should be, so that in solving you are only confirming what you feel should be the answer. How you got value. Alright, so that will be all for this particular calculation today. And don't forget, the third series, which is going to be the conclusion of this heat energy for us, will be on calculating the quantity of heat energy supplied to a body. If I use an electric heater, for example, what will be the quantity of heat supplied when I'm calculating with current and voltage and all of that. So please subscribe to this channel so that when that video is uploaded, you will be able to get the link to it and you get notified. If you have any question on this topic or any other topic in physics or chemistry and even mathematics, please do drop them online. And we're going to do our best to respond to your questions as soon as possible. Do have a wonderful day. Stay the online side tutor. Enjoy your day.